Hello, hello. So this is going to be one of these long videos with quite a lot of content to go through. Hopefully my voice is going to manage, because with the temperature change it's been kind of difficult. So anyway, the video is long and there are chapters for all the important elements, so feel free to jump directly to the section that interests you. And contrary to many videos, for that one I have a script because there's quite a lot of things to go through. So basically, since there is quite a lot of people who have no idea what the OSDK is, I will start by some historical explanations that explain what the SDK was originally and how it became the OSDK. The main part is OSDK 2.0 on the VS Code extension. They are totally interdependent topic because I had to change both to get them working together. And at the end, I'm going to cover the topic of AI use in the process. So if you don't want to hear anything about AI, it's just at the end. The rest has nothing to do with that. So, before the emulators and cross-development, we had to use the real machines. So, here's my Oric. Most of the games on software were made directly on the real hardware, with some exceptions, like Xenon 1, which was actually, I think, made on Accor BBC, with more memory on the disk drive, and then the data was transferred to the Oric with a cable. But that's not the main case on the Oric. But even if you do that, you still at some point had to debug the software. And to debug the software, you had to use one of these things, which are assembler, disassembler monitors. And the most common one on the Oric is that one from Tansoft, and there is also monitor 1.0 from Logiciel, and yeah, that one is Oric, so it's not really a disassembler, a monitor, it's a disassembler, and same thing with that one. And the main problem with these things is that they had to fit in memory at the same time as the program itself, which means the user interface is not very good. So here, for example, we have OricMon, that's the user manual, that starts by some explanations about assembler, binary numbers, etc. And then we go to the core of the thing. So you load cload OricMon, you call 9000, and then you got just a simple prompt. And all the commands are like directly X values or very simple commands. Let's see if there is a list of commands somewhere. No, there is addressing mode. Yes. If you put just a 4-digit X value, it shows the content. If you put 2 values, it shows the range. And so you see, subtract, it's always command you have to remember by heart. They are just like M for move, V for verify, L for disassembly. I guess it's listing. So not very user friendly. And fortunately, we don't have to do that anymore. And now we can do things much more comfortably. So the original SDK was a project started in 1994 by 3 persons, Alexios Tuchoulas, Vangelis Blatras, and Fabrice Frances. It's not clear who did what, but basically Alexios did most of the original C toolchain, Vangelis worked on the linker, Fabrice made the euphoric emulator, and the 3 of them worked on a set of libraries used to access the ROM, the system function, etc. And I wrote adaptation because the compiler is actually from university project, David Hanson and Chris Fraser, retargetable on CC compiler. So this is if you want some information. And this thing has been embedded in quite a few projects. Alexio has a complete article, is originally from 94, as you can see, where what is an Oric, introduction, and what you can do with the system. So yeah, it's how to program on in C on the Oric. The thing is, it does not work in the same way as most other systems. So in a traditional toolchain, you have a C compiler who takes a C source file, and it converted to an object file, which is a binary format. And your assembler does the same thing, and eventually, back in DOS, we had something called big to obj, where you could take a picture or etc., and it will convert it to an object file. And then you get the linker, who take all these object file, group them together to find out any external reference it's missing. And from that, you get a lib file, which are the missing references, and you end up with an executable. On the Oric system, it's completely different. And it tends to be like a curveball for people who don't really know how it works. So your C compiler transforms your C source code into an assembler file. So you start with main.c and you end up with main.s. The assembler files, they are not touched at all. And binary files up to OSDK 1.23, they had to be converted to text file with bin to text. But now you can do .bin to include them directly in your assembler file. And then the linker actually links assembler source file. It glues together your main.s, your various modules in one single linked.s in the temp folder. And that's also the linker that track each reference, what's missing, and uses lib library index, which is a list of all the modules and all the symbols on which file you can load them. And it glues that, and your output is a single linked S assembler source file, which then get passed to the assembler, which generates the executable. And of course, there are things like adding headers and conversion to tape on disk format, etc. But the important point is that at no point there is a binary object file. It's all one single big assembler file, which is actually very nice to do like partial optimization. You don't have to do crazy things. You just take the C module and yeah, it's converted to assembler. You can use it. It also makes it very easy to do memory map analysis because it's a self-contained program. There is no surprise, nothing added from the outside. And another advantage is that potentially you can get your source code through what's called a people optimizer and basically apply global optimization on the entire source code. You can also strip dead code, functions which are never called, etc. So it's quite nice. So what is OSDK? So I was not part of the original toolchain development. I only rediscovered the Oric around 96 when I got a magazine with a cover CD which had a Oric on it, and there were a folder with the Oric C environment. So I made a few test programs, but realized quite fast that yeah, it's nice to be able to do C on assembler, but if you want to make games or demos, you need to be able to convert pictures and on sound, and yeah, so it was not sufficient. So I came up with a few more tools like YM to MYM, which is based on some MS6 software, on PictConf to convert PC like PNGs, GIF, or to an Oric format. And I also got fed up with the limitation of the original assembler. The original toolchain was using Phrasm, the Frankenstein assembler, which was very limited. It had no meta function, nothing. And so I replaced it by XR from André Fachat. And in March 2001, the first OSDK version was released. So if we go here to download, at the very bottom, you can see OSDK version 1, March 2001. And since then, there have been quite a few versions. 2012, 14, Oric upgrade, floppy builder, etc., etc. And now you can see version 123, April 2026. It was totally possible to debug in the existing system before. So we had Oric, the original good emulator, but from the DOS era, which, as you can see, has a complete interface. Press 11, F11, and then you can see the source code, the CPU register, the 0 page, some data watch, breakpoints, the state of the VIA 6522. And then you can trace, show the Oric screen, can crash, etc., etc. And you have some small command to change the display. And then after that, we got Oric. So Oric is not technically better than Euphoric, but it has a big advantage, which is it returns 100% in C. It came after Euphoric. Euphoric is from the DOS era, so it had a lot of x86 assembler, which made it hard to port. So as you can see, Oric is kind of similar. The main difference here is that you have an area for the screen, so you can see directly what happens while you are working. But for the rest, you have the same thing. You have the instructions, VIS status, and then you can use that to watch memory, inspect variables, etc. And it has a few more commands than Euphoric. How did it work to use that in the old system? So here I have a simple Hello World program, which is a mix of C and assembler. I press Ctrl B, and I have Hello World, and yeah, it executed and nothing happened, and I can't stop and I can't inspect, because you can't put breakpoints. So you had to do things like adding a shortcut, and then it will get stuck, and then you press F2, and now you can see that my simple print is a jump symbol print, and then you could press the F12 key to skip this instruction, and now we can trace. So LDY0, LDA SPY, STA. So you can inspect M0955. You can see as value 23. I step in, and now it's D1 here. And so technically that works. And you can see all the registers that change, and etc., etc. And you can see the hello appearing here, character by character, and I can press F10, blah, 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 hello world. RTS, now I'm back to the C code here. Or am I? Do next line. No, now I'm in the ROM. As you can see, C8, C1. So yeah, it's very primitive. You can't put breakpoint. You have to use a hardcore breakpoint like that. So not awesome. Also, you only see 10 lines of code. Symbols are truncated, and there is no persistency. And as you can see, there is no way to trace the C. And when you trace the C, you're basically tracing assembler, which is not awesome. So when I worked on Encounter on Cybernova, that was very big limitations. It worked very nicely for small programs, especially if they are all assembler. But even then, you lose all these commands. You don't see them anymore. Instead of STA read, you see whatever read is pointing to, which is in this case, it's automatified here. You don't see the label. So yeah, not very practical, only become challenging the bigger the program become. Debugging after version 2.0, which is not yet available at the time of I'm recording this video. I'm going to update the description of the video as soon as I have something that's available. Hopefully I should have something 1 week from now. So there are multiple ways of doing that, but I've been using VS Code for a while and liked it, so I decided to go for an extension for Visual Code. Considering it's written in JavaScript, I think VS Code is actually nice. Generally speaking, it's getting better and better, and Visual Studio is getting a lot worse, despite being written in native language, so yeah. Poor Visual Studio. But the extension is only one part of the system, and it needs to talk to a real debugger. And for that, it needs improved debugging information, and for doing that, we have to modify the compiler, and the linker, and the assembler. So ultimately, pretty much all the elements of the toolchain had to be modified. But now, what we have is something like that. So, I can put my breakpoint. I can press Ctrl-Shift-D to have a debugger. I have a few elements like that. Yeah, I don't have any watch here. So let's see, I want a screen view up, and I press F5. So as before, my emulator view is here, but now I also have a view here, which is the streamed view of Oric. And you can see here we have a symbol that tells us it's paused. And I have a few options, like I can show a grid, I can change the aspect ratio, and I can have a nice CRT pseudo effect. I can also save the image, screenshot saved, and I can copy it to the clipboard, and I can open a folder with all the screenshots, which you can see here. So I run CLS up, which is in the ROM, and here I'm in the CLS. I can trace. So there is not much better information here because I'm in the ROM, so not particularly useful, but at least I can see a lot of lines. And as you can see, there's also something cool here, which is 7-step back. So what I can do is Shift F10. So I can reverse in memory. I can press Shift 11 to exit and go to the next RTS. So simple print. I'm going to put a breakpoint here. I restart. I'm going to put a breakpoint here as well. So all that is in development, so I can't guarantee it's 100% bug-free. So where is my simple print? So I want to find simple print. So for that, what I can do is to use the symbol browser and simple print. Click here, and then I can put a breakpoint here. Now I'm tracing not in assembler with LDA, STAP, STA9. Now I can see STA read +1. And I can see all my commands. And I can go there, and I can do run to here. But as you can see, I can also break into the C program. And here we have a variable called value, and value is 5. As you can see, it was pasted here. Now value is 4. Okay, let me force that. 3, 2, 1, 0, quit. So there you go. We have full symbolic tracing. It's a bit more practical when the window is full size, but I had to condense that a bit. You can enable or disable the breakpoint here. But you can also do some cool things, like here you can right-click, add a log point, value loop, and let me disable that one, and that one, and that one, and that one. And it showed value loop 5 times. And now the question is, value equal value, will it work or will it miserably fail? And there we go. Now I have a watch point, loop value which show 5, 4, 3, 2, 1. So it's not perfect, and it does not work in all cases. So config, it works here because I'm compiling with global symbol export. If I go there and I build, yeah, now we have an orange symbol and it's written unverified. No source line info for the C file, rebuild with -G1, set OSDK comp equal -01. So G1 means export line information symbols, and -01 is disable optimization. And it's necessary, else we don't have access to the stack frame parameters, so we can't show the variables. But the problem with that is that it takes a lot of room, because -03 or 02, it's very much more efficient. 01 is very fat. Here you can see 7 bytes of data, 690 bytes of data. And if we do that, now we don't have access to the local anymore. So anyway, to do that, we had to modify Oric. So this is not a standard version of Oric. To get that to work, I needed to implement a GDB protocol interface, and then quickly run out in a problem with the limitations of Oric, because it's designed to be using manually BL list breakpoint, BS set breakpoint. You rarely end up having many breakpoints, but when it's so easy as you just click on lines, you end up easily with 20, 30, 40 breakpoints. And Oric was limited to 16, so we had to extend that to 64. Then there were problems with limitation in the evaluation. It did not support all. There were no generic expression evaluator, so we had to implement that. And this view here is not supported by the GDB interface. It's basically a real-time streaming. So there were a second interface that had to be implemented, dedicated to sending data and also inputting real-time events like the keyboard. And which brings us to the debug adapter protocol. So this is what Visual Code supports and many other things. Basically, it's a standardized set of a function that you can implement to implement tools, to basically drive the debugging process, profilers, something like that. It's been implemented in quite a few things, quite a few tools, there are quite a few plugins. ESP32 debugger, Erlang debugger, Godot, etc., etc. And there are actually quite a few existing such interface for other retro machine, Atari ST, Amiga, 8-bit Atari. So I looked at them to see what was possible to do, and the conclusion was that if it can be expressed in JavaScript on network, you can do it. So video, internal exploration, visualizing things, yeah, it's all possible. So the other big problem was that the C compiler did not have any line tracking, so we had to add the standard thing like files, the C line, etc. And that had to go through all the part of the pipeline. So it's nice to have your C compiler to export some directives to allow trace. But if it's munched and eaten out by the linker and by the assembler, that's not working very well. And we also wanted to be backward compatible with all projects. So there is a new assembler parameter you can add to have extended symbols, which is in addition to the normal symbols. So if anyone made some parser for the old symbol files, it still works. If you're still using an old Oric or Oric, it still works. It's still the same format. And as I was saying, there were a problem with the performance on the size. So we added some Pragma here. Pragma optimize push. So here I'm going to compile in -O2, and I'm going to comment out that. And if we look at locals, it looks like G is missing. If I enable the optimize, basically we can inspect the variables. Here we can see we have an entity with a name, on the type, on an inventory, and we can see that. And we have also a watch mode, where we can inspect the entities. Oric symbol browser, G entities. So we have the entries here. There are also other nice things which have been done. So press play. Warp mode. Yes, there is also a fast forward mode. Up and pause. And now we have the video explorer. So it's possible to add any variable. Let's see if I go to last module, and I want to see the table of modulo 6. I can do that. Add. And here I can see 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. And this is the content of this table. And if when tracing, if the content changes, this is refreshed. These are the actual sprites using a special video mode. So they are the mask sprite, so we can change the background. And this is the compositing buffer. So if I search for image buffer, it is here. It's a big 440 by 128 buffer. Add fancy image frame. So I put a breakpoint here, and then I can go. Yep, I have to run, but maybe. Now we freeze, and we are on the Oric memory map. So the tunnel has been loaded, and now I can enter here, and so put, yeah, on that one it's not going to be very visible, so let's see, I can turbo run here. Now I have my white line here, and then I'm going to put the two sides, run to here. Now we have the line here, on the line here, and then the three lines at the bottom. As you can see, things are updating. Now with the line, and they are not pretty. So now the corner is fixed, and that corner is fixed as well. And now we can draw the arrows. And for that, I'm going to put a breakpoint on block and here, and up, up. We have the black shape, the gray out shape, the top arrow and the bottom arrow. And I can go back. And crossfade buffer to iris window. Put a breakpoint here. And you can see the crossfade. So all that is still kind of a work in progress, but this first version will have all these features plus whatever bug I can fix. Here, that one is one bug as well. Here you can see blend buffer to iris window internal, 130,000, yeah, 565 cycles. The code instruments all the things that happen all the time, but it does not always display. So there is a bug somewhere. Now XR support enums. So instead of define direction north equals 0, blah, 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 now we have an enum, which means XR can actually show. So, up. So now we are in print scene direction and current instruction. So we have the call stack. So here we can see we are in an assembler module, but we can see that it knows its current location pointer and that the new location is a fish pond. So basically the system tracks down based on that notation which pointer points to what. And the cool thing is here I did LDA current location because it knows that it loads the location. We can see that A contains the location fish pond of type location ID. So that needs to be extended. The UI probably need to be improved. The problem, yeah, here we can see fish pond as well. The problem here is that this is an extension specific UI, and that one is from VS Code. On the VS Code one has very big limitations on what you can do. Which is why some has been remade, but not everything has been re-implemented, so they would need some changes. Yeah, so another important thing was the module support. When you are doing Hello World, obviously there is only one module, that's not a problem, but Encounter has multiple modules. So now we have the module support. Here you can see splash, intro, game, outro, king. So I'm going to take my breakpoint and disable them all, except I'm going to go to splash main. I'm going to put a breakpoint here. So here you can see we are in module splash. And intro main. So now we are in the module intro, and it matters because all these modules have their breakpoints automatically enabled and disabled, so you don't have the problem of having a random breakpoint triggering at random location, because that one was at a fixed address which mapped to something in Splash, but now in the intro it does not mean anything anymore. So all this thing works. And to do that, OSDK debug module, the debugger tracks the content of this specifically named variable OSDK underscore dbg underscore module. FF means there is no module. If the variable does not exist, it means there is no module support. And yeah, game utils. For example, when we enter Monkey Kong, we temporarily set the value. It should be defined, but it's not the case. To say, yeah, now we are in Monkey King module, and then when the game is finished, we restore the OSDK module ID, which is the current ID for the current module. So that needs to be streamlined, but the bottom line is it does work. So annotations, there is an entire set of annotation you can use. And the cool thing is, basically by doing that, you can have the debugger automatically expand a command with all the parameters behind. So it does not necessarily know what's what, but here it knows that to jump it through, it will automatically show the parameter on where things are jumping. Here we can see that it knows that current stream is a stream pointer. The command here is displayed, and we know that at address 32, so let's see, G current stream, I can add a watch. Actually, I have what here. It's on flag weight. So we see here it resolves most of the elements. So it knows that byte stream callback is at address 1CB4, and it knows that X is set to value 12 hexa, which is this value, and then because it's an address, that points to the value 19 hexa, which got loaded in A. Here it knows that current stream stop is of type stream stop flags, and it knows that the value is flag is running. Yeah, so another nice thing is snapshots. So I showed earlier that we can execute backward, and it's because Oric supports snapshots. But we can do other things with snapshots. We can do things like immediately rewind to a location. Here we are in the kitchen. And here that's when the fridge has been opened and the peas have been crushed. And here is the start of the game. And here it's the mossy... so I can take the wooden bucket. Automated testing. So let me stop that, and then I can press play. So I probably should remove all the breakpoint. So it basically runs the game, and automatically I can show the script here. So it drops the newspaper, it drops the plan, takes the deposit, put it in the bag, go north, go west, take the rope, go east, and automation for test passed. And the script is basically just that. So wait until the module is loaded, check what's the name of the module. If it's a splash screen, need to press space to exit, and have to wait until we are a different module. If we are in the outro, so the credits, same thing, press space. If we're in the intro, we need to press escape. And then we need to wait until game starts, and then press space again. And then go through the cutscene, wait until we are at the marketplace in warp mode, and then with the command take the bag, drop newspaper, drop plan, etc., etc. So with that, you can basically automate going through the entire thing. And you can have command like take a screenshot where you are, save a snapshot where you are, which means you can also do memory tests. So you can put kind of assertions and automatically save a snapshot if some specific condition is met, and print a message in the output, which could probably help during regression testing. You change something, you optimize some code. Is it broken? And with all that, we can automate even more. So, Oric documentation. Yeah, so we have also a few documentation bits here. With the manual for the extension, with all the features. There is a XR reference. So, how does the text? Here we have same thing, but for the 6502. So how does STA works? And you have all the commands directly. The one in yellow are for the 65C02, so they are not supported. Links to the OSDK website, and you can open all the memory views from here directly. Let's try. I have not retried that since. Okay. So, snapshot, encounter, D2 pills. Alright, so I reloaded the pills crushed snapshot. Could you try to find somewhere to use that? And here you can see at the bottom AI bridge off. Let me pull up the playthrough state on the game interaction notes before I touch the emulator. Got it. Let me attach to the running Oric session and confirm state before doing anything. It's enabled. Let me take control. Now you can see AI bridge, AI piloting, combine, pills, meet. Okay, that's going to be annoying. Let's move that here. So you can see it took a screenshot. Good, that should knock it out. The crush pills are now used. Where we stand, the pill puzzle chain is complete, mortar crush, then combine with the meat to make sedative bait. Next logical move is to take the drug meat and go find the guard dog. We are 7 inventory items, so taking the it. We may, yeah, go ahead. Want me to keep going, grab the meat and start hunting for the dog, or pause here? And yeah, it forgot the drug meat in the inventory. Yeah, so that's one of the problems with the keyboard. It tried to type take meat, but with the pause, resume, things happen to not work. Interesting, a few things happen. Score jumped to 200. The fridge now shows drug meat, Encroach pills, vanish from inventory. So the combi did consume the pills, but my tech meat got scrambled to eat. A message core animation was still playing when I typed, so the leading keystrokes were eaten. The classic modal eats keys pitfall. The meat is not yet in inventory. Let me clear the stray eat and retry cleanly. Yeah, drugged meat. Thinking, 7 token, 800 token. I now hold the drugged meat, inventory shows it. The fridge description drops the meat. We are at 7 items, score 300. Now to find the guard. The house interior past the kitchen is unexplored. Let me read the exit cross to see which directions are available before moving. And so, to be clear, this is slow because Claude has not been allowed to read any of the internals. So it does not read any of the source code, internal variables or anything. It could. It has access to all of that. But I told it to try to play the game just by looking at the screen, which is why it has to take screenshots. And by entering input commands. So by providing dedicated function for that, like look here, look there, it could do it much faster. But the idea was, can it do it? South didn't move it. Move us. We are seeing the kitchen, the article screen, no error, so that down arrow was not an exit. Let me examine the exit cross carefully at high scale to reach which harms are actually white available. So the desired arrows are not locations you can go, but here there's also a little downward arrow that indicates you can go down, not just up, not just north, south, east, west. Oops. Yeah, so it was confused by the down arrow. It thought it was south. It's D to go down, to go up. So while it's playing, or failing to play, AI use. So I could have done all that by hand, because I've been spending years working on tools. But ultimately, tools are not the end game. It's just a mean to an end, which is make stuff on Oric, games, demo, etc. So this extension was written about 99% by Claude, mix of Fable 5 and Opus 4.8. And all the change to the compiler, linker, assembler libraries as well. It still took more than 1 week, my entire week, first week of holidays, to do much of that. Because yes, even if you use AI, you still need to have somebody that review the user interface. Is it usable? Does it even work at all? Find that, yeah, okay, technically that works, but there's no way that anyone could figure out how that works. The AI would not came with the idea of implementing the Heatmap, which I forgot to show. Build the demo. So here you can see the entire Oric memory map, every byte which been changed, all the activity in 0 page, page 2. So in green, that's all the reads. In red, that's all the writes. So yellow is a mix of read and write, which is generally the decompression. And blue is the video chip reads. So when you see purple, it means the location which are read by the video chip and written by the CPU at the same time, which is all the purple pixels. And you can see these patterns indicate basically, oh, was there any progress here? Let me pause. Go back to Encounter. Okay, it managed to go to the basement. We descended, new location, watch your step, a staircase, there is nothing of interest here. It's a transitional stairwell. Let me keep going down towards the cellar. So it types D again. Took a screenshot. Descended again into, is that a Franz Jäger safe? A cellar room with a heavy safe, a nice die-hard node? No. No guard here yet. The exit cross show more downward diagonal arrows. Let me keep descending toward where the girl is probably, a guard will be. Oh no, that's wrong. The other diagonal arrow means the upward direction. But there is another direction indicated on the cross. D didn't move us, the safe room is the bottom of the stairs, so the other exit here are compass direction, not down. Let me read the exit cross precisely before guessing. So that's the problem with pixel art, especially black and white, is that the image recognition model sometimes is struggling with the dithering. Now I can read it, thanks for the guidance. The up, right diagonal up, back up the stairs. The prominent solid white down arrow, the other exit, that's south, leading deeper into the cellar. South leads to, the window seems to be covered. I can see a darkened window on a flashing light. This is almost certainly the inside of that cellar window. We saw seal from the garden, can't peel it off from here. The flashing light reads like an alarm sensor. We are getting close to the hideout. Let me read the exits here before moving. Maybe there are things you could actually do here. The exit cross here shows only a north arm back to the safe room, so this is a dead-end cellar branch, not a path to the girl. The two flashing marks in the scene are the flashing light. On the desert panel is the covered darkened window, the inside of the sealed cellar window we saw from the garden. No dog or girl down here. Before I wander further, let me examine what's actually interactive in this room. I'll open the verb menu, empty return to see the valid nouns reliably. The user's right, there's likely something to do here. Let me see the verb noun menu I just opened. The verb menu is open, look highlighted. Let me select look to reveal the valid nouns in this room. Valid noun here, the scenery is window on light. The rest are my inventory. So there are two things to interact with. Let me examine the flashing light first to understand it, moving right to it. Look like selected, confirming with return. The flashing light, it blinks on beeps. An alarm motion sensor. Now let me actually do something rather than just look. The covered window, sealed per the Virgin Garden clue, is the obvious action target. Let me try to open it, first letting the message clear. So it types open window. I can't reach it. The window's too high. I'm carrying the ladder. Let me use it to reach. So I didn't tell anything to the system. The only thing I told it was things like try to wait not as long between screenshots, because sometimes you are missing some messages because you waited too long. So I basically told it how to use the game, not how to play it. The use got eaten again. Message was still clearing. Line reads just ladder, clearing, on retyping cleanly. Press del, press del, press del. So it's not a very efficient way of doing things. But yeah, it shows that basically you can get AI model to do things on your Oric program. So technically, you could probably use that to try to automate finding a bug. Right, layers in place. So yeah, back to the AI thing. There are a lot of things that worked, but like there were no UI shortcut for it, so you had to use the palette, or the name made no sense, or the UI in the icon in the UI were like black over dark gray. The invert video was not working at all in the memory viewer. There were a bunch of features that would silently fail if one of the parameters was not correct, etc., etc. So in terms of feature, what was requested was most of the time one shot by Claude. It is very good at understanding what you want, and I'm not judging the implementation, or I'm saying that I'm judging the does it work. And in most cases, it did work. Maybe there were one or two exceptions where it had to backtrack, but most of the time, it worked first time. But it took twice as long to get it to the state where it's actually nice to use on the kind of thing you would deliver to a human saying, yeah, I'm done. And that's what people are generally missing when they talk about, yeah, AI doing all the work. No, AI is doing a part of the work, but still your job to check if it's correct. If you make an Oric emulator and it does not emulate correctly the display, a part of your job is to actually run a selection of, I don't know, slideshow to check if it renders all the images correctly, some music disk to check if the audio is replayed correctly, some basic program, some C program, some assembler program, some complicated things for disk. And all that should be caught in a normal testing. But if you don't do it, you have no idea if it works. And the tests are as good as the specification were. So if you don't know the actual thing you have to test, I need to actually climb the ladder to get up the window, placing the ladder at the up arrow. So it detected the thing here. Yeah, so can it be done without AI? Yeah, definitely. But I'm not a great JavaScript programmer. Web dev is not my stuff. I don't know. I have used GDB, but I have never programmed the GDB protocol. I know the DAB, I know what MCP is, I know what a VS Code extension is, but I never written any of that. So I would have to read heaps of documentation, and it would have taken months to do basically what I did in 1 week. Would have been better without AI? Yes and no. Most probably the implementation of the feature would have been much more tight and more maintainable, I guess. But it would have taken me so much more time that I would probably have implemented maybe only half of the feature, because everything which looks like a small quick win, nice to have, which takes like 10 minutes to the AI to implement, can easily take a full afternoon. And when you have a main job which is not making thing for the Oric, it's easy to decide that it was not worth the effort. And so we can see that tech tape ripped to shred, no use now, the covering is off, the window should be uncovered now, let me see the updated scene. The tape is gone, the window is uncovered now, I can see a window on the ladder ready to climb. I'm up on the ladder at the window, let me open it. That's going to be interesting. We will see how AI system handle failure. Because as a human, you can immediately see that there is a small exclamation mark symbol here, and the three things on the window with a wire, and there were an alarm station. So open window. The frame is stuck. Suspense. The frame is stuck. The window won't budge. I have a silver knife that could pry it. Let me try using the knife on the stuck frame, letting the message clear first. Maybe shake it a bit? The game hints, maybe shake it a bit, so the action is to shake the stuck window. Let me try that verb. Display is mid-transition, let it settle. I've triggered the alarm. Wee-oo, wee-oo, wee-oo. Uh-oh, I've triggered the alarm. Red banner, blaring siren. That flashing light was an alarm sensor, forcing the Windows set it off. This is a setback. Let me see what happens next. The alarm screen is holding, clock frozen, it's likely waiting for a key press to continue. Let me press space to proceed and see the outcome. And that's a bug. This one is actually a bug I've had for the last 2 years. It's very, very rare, but it happened twice this week. So that's why I took a snapshot. I see the right minute, key lesson. Well, you triggered the marketplace image bug. There is actually some documented memories somewhere about the issue. Maybe you can find that. So yeah, there you go. I was hoping that Claude will find the dog, but I mean it managed to trigger. Okay, investigate and fix it. We'll see how it can. So yeah, so that was all I wanted to show. So obviously, as you can see, there are still some bugs, but the core of the features are here. When will that be released? I don't know. There will probably be some beta test version available maybe next week. And yeah, that's all for today. It was 1 hour 18, so I guess I have some editing to do. Bye bye!